So as we continue working on lesson 7.7, and now that you know the steps for factoring these trinomials that have a leading coefficient, we're going to kind of bridge that together with the zero product property and solve equations. So if you noticed, when we started this process, I really only focused on you getting down those steps for factoring, and we didn't solve anything really. We just practiced the factoring steps. And now that you have a little bit of practice under your belt, we're going to just bring it together with the zero product property that we continue, to talk about. So if you notice a difference on problems like number 1 and 2 here, we're solving by factoring using the zero product property. So we'll do the steps you learned yesterday, but then we will set each factor equal to 0 and actually go all the way home here by solving, finding the solutions. So really quick recap. Before we start that, right, step number 1, no matter what, is make sure that it is set equal to 0. So if it isn't, move everything so that it's all on the same, all your terms are on one side and nothing is on the other side, so it's equal to 0. Then you'll apply what you learned and practiced over the last, day or two, and factor these trinomials. And then once you have it written in factored form equal to 0, then we can solve, with the zero product property. So that's kind of our game plan each time. Let's try it with number 1. So first things first, is it equal to 0? That's question number 1, right? So we're like, yes, it's equal to 0. So we're okay on that. Number 2. Is there a GCF among my terms? If I look at 5, 21, 18, or variable or number, right? Is there anything they have in common? So we look at that for a moment, and I think we've all agreed, nope, there isn't. No problem. Then we can proceed. Because there is a number in front of x squared, we now know that before we play our little magic number game, we're actually going to multiply these guys together and use that in our little magic number game. So we're going to do 5 times 18, which gives us a product of 90, and that's what I'll use when I'm trying to decide what the two numbers I want to use are. Okay, so I try to think what are 2 factors of 90, and that when I combine them or add them together, give me 21. And at this point, you should already know the calculator trick, so you can do that. If you're not sure or you don't have a calculator, you can just kind of make a little 90 here and just start coming up with those factor pairs like we had practiced a few days ago. And just go through and say, okay, 1 times 90, 2 times 45, and just go in numeric order so you don't skip anybody by mistake. 3 times 30. I believe 4 does not go in, but 5 and 18, obviously, because that's how I got that just a moment ago. None of those still add up to 21, but then I also know that 6 times 15 works. So I'm like, there you go. Those add up to 21. There it is. So 6 and 15. And lets me now rewrite my polynomial. And instead of writing those 21x's together, we will separate them out into a 6x and a 15x. And no, it does not matter which one you write first, as long as the signs are correct. And now that we have split that middle term up into those two there, those two are equivalent, then we have 1, 2, 3, 4 terms now, and we can factor by grouping. So we group the first two and the last two, and we do a GCF factor. So in the first group, there's a common factor of x. That's going to leave me with 5x plus 6. That is all that those two terms had in common. In the next one, 15 and 18 have a factor of 3 in common, so I'll factor that out. And I get a 15 and a 6. And then that's equal to 0. Okay? All right, awesome. And then we say, oh, look, there's 5x plus 6 on both, so that's one of my factors. The other factor is going to be the x plus 3, which were the two GCFs. And yesterday, this would have been the stopping point. But now we have an equation, right? It wasn't just the expression, the polynomial in front of us. We now have an equation involving this. And so if this times this is 0, I can actually take this all the way to the finish line, set each one of these binomial factors equal to 0. That's equal 0. So this will be true if 5x plus 6 is equal to 0, or if x plus 3 is equal to 0. And then I need to solve both of those to get the actual solutions for this polynomial. So here we'll subtract 6 on both sides. And after that, I'll divide by 5. So one of our solutions is that x would be a negative 6 over 5. The other solution is if I said x plus 3 equal to 0 and subtract the 3, that gets x alone, and that'd be a negative 3. So these are the two solutions that make this polynomial equation true. There you go. Okay, let's try number 2. Let's try another one. So you can see it's really just practicing the steps you learned yesterday for trinomials that do have a leading coefficient and bridging that together with a zero product property work we had already been doing. So let's try number 2. Let's try one more like this. Let's see if there's a GCF, and if there is, pull it. But 12, 7, and 10 don't have anything in common, and not all of these terms have a variable. Then just remember, because of this 12, we need to multiply these guys first and use that in our magic number trick. So we say, okay, that's a negative 120, and it's negative, so I'm looking for a difference of negative 7. So if they're negative, I know my signs are different. If my signs are different, I know I'm looking for a difference. So two factors of negative 120 that when I combine them, combine to negative 7. Okay, and again, you can make your little factor tree. You might already know. You might use the calculator trick that I taught you in class. But the magic numbers here end up being a negative 15 and a positive 8. Those multiply to negative 120, but combine to negative 7. That lets me now rewrite my polynomial, splitting the middle term with a negative 15h plus 8h. Everything else stays exactly the same. Right, that's that, that's that. And now we can factor by grouping because we've got 4 terms. Okay? So in the first group, these guys have a 3h in common. And that leaves me with 4h minus 5. And in the second group, we can pull a 2 from that, and that'll be 4h minus 5. And then we factor it completely here and know that one of our factors is that 4h minus 5, and the other parentheses, the other binomial factor, is those GCFs, the 3h and the positive 2. And the big difference today is that I now take this all the way to the finish line, right? Since I have this times this equals 0 now, then I can set each factor equal to 0 by the logic of the zero product property and find out what these solutions must be. I'm going to give myself a little bit more space here. Ha! Okay. Probably helps if I move that. Okay. So give us a little bit more space here and solve these two little mini equations. So it's just a two-step equation at this point. Add 5 on both sides. Divide by 4. So one of our solutions is that h would be equal to 5/4. The other possible solution, or the actual solution, is when we solve this one. So we'll subtract 2. That's 3h is equal to negative 2. Divide both sides, and the other solution is when h is negative 2/3. And those are the solutions to that polynomial equation. Okay. All right. So if once we have now we have seen a couple of practice scenarios, and how we're bringing together the steps for solving these trinomials that have a leading coefficient with what we had learned with the zero product property. Let's take a look at 3 or 4. I want you to notice that the main change or difference here between numbers 3 and 4 is that they're not set equal to 0. Right? That's one of the first things. We look for a GCF, and then we set equal to 0. Or actually even the other way around. Set it equal to 0, then factor, right? So it doesn't really matter which one. I guess well, let's do number 3. Okay? So I don't want to start factoring this if it's not equal to 0. I really need everything on one side equal to 0 before I begin the factoring process. So, like my life depended on it, the first thing I've got to make sure I do is move the 5 to the left so that there is nothing on this side. Okay? So, the new polynomial that I'm actually going to be interested in factoring is negative 20b squared plus 56b when I combine a negative 10 and a negative 5, I'll get a negative 15 here equals 0. This is what I'm interested in factoring. Okay, that other one before that, that was not what we needed. Okay, and so one thing that usually makes this process easier, guys, is actually when you're leading. We haven't talked about this yet, but it comes up today, so let's chat about it. You don't necessarily have to do this in this particular step, but you will later anyway, so it's good to start now. When your leading coefficient is a negative, that little trick with the magic numbers, it gets a little bit, sometimes it makes it a little harder. So we like to get into the habit of factoring out a negative if the leading term is negative. So actually one of the, when we look for a GCF here, you can consider a GCF a -1 or the negative of GCF if the leading term has it. So I'm going to think of this. When I see this, it's going to pop in my head, oh, there's a GCF. If nothing else, there's a GCF of -1 here. I'm going to pull that negative, or that -1, however you want to think of it, and I'm going to turn this into a positive 20v squared. It's now, this is going to now be a negative. Remember, just switches all your signs, right? And a positive 15. Okay? And that's really the only GCF, is that -1. Okay, so negative or -1. All right, now let's start factoring. Because we have that 20, remember, we got to multiply the 20 and the 15 first. And 20 times 15 happens to be 300. And we're going to look for two factors of 300 that combine to -56. And that one's actually pretty easy, just because I know that 50 and 6 gives me 300. So, of course, you could do the other tricks and the calculator stuff, but pretty quickly I'm going to figure out, oh, it's -50 and -6. So then we'll rewrite this, splitting up that middle term. So we're going to split up that -56 into a -50v and a -6v in any order is fine. Okay. And you can keep the negative out in front, that's fine, and the 0. Just right now we're working inside here. So, all right. And then we're going to group the first two, group the last two, and pull, do our factoring by grouping here. So I see that I can pull a 10v out of this first group, leaving me a 2v minus 5. In this group, I'm going to have to pull not just a 3, but a -3, so my signs can be matching here. So I'll pull a -3, so I'll get a positive 2v and a -5. Remember, I always want to make sure those parentheses match. Okay, and then, outside of this, we still have the equal 0 and the negative, no big deal. And then I just write my factors. So my factors here are the 2v minus 5 that we came up with, and those GCFs, the 10v minus the 3. Okay, and I still have that negative out in front, and this is still equal to 0, and we're still going to use a 0 product property. Now remember, we talked about this a little bit ago when we first introduced the 0 product property. If you have, even if you put a negative or a -1 here, it doesn't really matter. If you have a GCF that is just a constant, just a number, and it does not involve variables, then when we go to use a 0 product property, we don't have to worry about it. Okay, we're really only going to focus on the factors that actually contain my variable. In this case, the 2v minus 5. You've got to set that equal to 0 and solve it. And the 10v minus 3. We got to set that guy and equal to 0 and solve it. And the rest of it should start to just really feel very familiar, like deja vu. We've done this for quite a bit now. Divide by 2, divide by 2. One of our solutions is v equals 5 over 2. So the other one is if we add 3, we get 10v is equal to 3, and then we divide. And the other solution is that v is 3/10. So this is one solution. That's the other solution. Okay? So if it's not equal to 0, the moral of the story is set it equal to 0. And if there's a negative in the leading coefficient, go ahead and get comfortable pulling it. It's actually going to make your life easier a little later. And I do think it makes the little magic number process a little bit easier a lot of the time. All right, so you're going to have a few extra ones like number 4. If you want to try those on your own and check them against the answer key, let's just do one more with a little bit more complex, stuff. So let's see, it doesn't really matter which one we do here. I guess we could do number 5 and maybe leave the last one here, number 6, in case you want extra practice. So First things first, set it equal to 0. Remember, that was number 1 on our game plan. So let's set it equal to 0. We'll move the 6k by doing the opposite, the negative. And when I do it on this side, I'm going to go ahead and just line it up, right? Because that's a like term that I'm going to be combining it with it anyway. I'm also going to move the 1. So when I subtract 1 on this side, I'm going to line it up with my constant because that's where it's going to combine. So that takes care of this, and that'll leave 0 on the right. So let's find out what our new polynomial is. It's negative 12k squared. Right there in the middle, now we just have a 20k and then a negative 3. And there's nothing left but a 0 on the right. So we're on the right track here. I am going to definitely do this one, but I'm going to go a little faster. So GCF, only the negative 1. That's going to leave me with a 12k squared minus a 20k plus 3. Okay. In fact, if you wanted to pause this one and try it and then check it, that's fine by me. I'm going to keep going. You can always pause me. And then I'm going to play the magic numbers, except I have the 12. So I'll do 12 times 3 first, which is 36. And I'll look for 2 factors of 36 that combine to a negative 20. And I'll realize that's got to be a negative 18 and a negative 2. I'll rewrite my trinomial into a 4-term polynomial because I'm going to split the negative 20 into a negative 18k and a negative 2k. And since I have 4 terms now, I will factor by grouping. And I'll look for a GCF in the first group. There'll be a 12k here, and that'll leave me with just k minus 3. Did I do something weird? 12 does not go into 18, Monsieur Reda. Gosh, I did that to make sure y'all were paying attention. Let's try that again. 6 is a GCF here. 6 and a k. There it goes. And that leaves me with 2k minus 3. There's so much. Still have that negative 1, by the way, hanging out. Over here, 1, but I do need the signs to match, so I'm not just going to pull a regular 1. I'm going to pull up a negative 1 so that this changes signs for me. This becomes a negative 3 signs. And now it matches. And so my 2 factors are 2k minus the 3 and a 6k minus 1. I have a negative 1 also. That isn't really going to make a big difference when it comes to the zero product property, but it is one of the factors of the original. So I want to honor it, by making sure it's still there. Now that we have it in factored form, really the only factors I need to worry about to establish a zero product property are the ones with variables. So I'll set this guy equal to 0. I will set that guy equal to 0. And I'll solve. Divide by 2. So if you paused it and you worked it and then you're checking and you got 3/2, 3 over 2, you are in good shape. And for the other one, if you got for your second case solution a 1/6, then you are a rock star officially. I knight you as a rock star. There it is. Okay, so K can be 3 over 2 or 1 over 6. All right, so now that we know the steps, okay, let's look at these problems from a few other perspectives, right? Number 7, find the coordinates of the points where the graph crosses the x-axis. So just a different kind of way to present to you or deliver the problem. But now you should be well aware, comfortably aware, that the x-intercepts, or the points where it crosses the x-axis, are the exact same solutions, zeros, roots that we've been solving for this whole time. Okay, so in other words, if I were to have graphed this problem right here, number 5, and then look to see where it crossed the x-axis, that graph would be crossing the x-axis at 3 over 2, which is 1.5, and at 1/6. That's where those x-intercepts would be. So they are synonymous. This is just looking at it from the more graphical, visual perspective. Okay? But the moral of the story is, if we want to know at what x coordinates this, intercepts, then basically what I want to know is what are the x values when this is 0, because that's when we are on the x-axis. So it's really no different than what we've been practicing for several problems now, right? It's really about taking that equation. So obviously, by the way, I'm doing number 8, not number 7. It's taking that equation, negative 5x squared plus 26x minus 5, setting it equal to 0, and doing exactly what we've been doing. Okay, so I'm going to go actually even faster on this one because, you know, at this point, we can do this in our sleep, I hope. GCF of negative 1 leaves us with 5x squared. Let's try that again. 5x squared, negative 26x and plus 5. And then we do the magic number trick. 5 times 5 is 25. What are two factors of 25 that combine to negative 26? That'd be the negative version of those guys right there. Negative 1 and negative 25 works. So then we rewrite this. And we factor by grouping. So in this first factor, they only have an x in common. In the second one, I'm going to pull, they have a 5 in common, and I'm going to pull a negative 5 so that I don't have sign issues. And then my factors are then the 5x minus 1. It was the common binomial, and the GCFs in the other one. I still have a negative 1 out in front that is true, and this is still equal to 0. But then when I use a zero product property, I don't need to worry about the negative 1, which kind of makes sense because looking at that picture, that only intercepts the x-axis twice. So it would make sense that I would only have 2 solutions. So we'll set this guy equal to 0 and solve it. Divide. So it looks like one of our intersects should be at 1/5. The other intercept should be at exactly 5. So let's see how realistic that sounds. 1/5 and 5. That's what I'm looking for on this graph. Does it look like that point right there could be at about 1/5? Yeah. Especially if this is going by 2. So if this is 2 right here, then it would be pretty close. And then that 5 would be right here between 4 and 6? Yes, yes it would. So that looks really reasonable as far as solutions based on the graph they gave us. So these are the 2 solutions, which graphically are the x-intercepts. Okay? All right, so let's go on to maybe a word problem. I know it's your favorite. You've been waiting for it the whole time. We are here. Okay? So let's try number 9. I think we're probably going to do 9 and 10 at least. We might do the rest in class. We shall see. Okay, so number 9, it says, the length of a rectangular patio is 8 feet less than its width. The area is 280 feet. Find the dimensions. So when it is not provided, you know exactly what I'm going to say. Draw a picture every single time. Most of us are, 99% visual learners. It will help us so much understand this problem to just give ourselves a visual. So the length is 8 feet less than twice the width. So which one do I know nothing about? The width. I know nothing about the width. That's going to be my unknown quantity or my variable, right? That's the one they gave me no information on. Okay, so that's my variable or my unknown. I do know that the length is 8 feet less than twice that width. Remember the very first lesson we did at the beginning of August, the first day of school when I met you? It was about translating things like this into expressions because it's so important. So hopefully you can set this up. And last but not least, this particular rectangle with these dimension relationships has an area of 280 square feet. Okay? So we know that because rectangles have an area formula that is length times width equals area, that tells me I can basically do the product of this width and this length, and that the result would have to be 280. Okay, now you've done a few like this now. This might look tempting because it's already separated out, but unfortunately these are not the factors we need because this is not equal to 0. So as we've done with a few other geometric problems in the past, we're going to actually have to distribute this and multiply it together, which is kind of the opposite of what we would normally do. We'd normally try to factor it out, but in this case we have to actually do that first. Move the 280 and say, hey, come join the party over here on the left. Okay, come on over, friend. And we move it over. So there's nothing on the right. and create what's essentially, guys, a new polynomial now. This is not the same. This is a different polynomial, but this one is set equal to 0. That's what we need. This is the one whose factors we're interested in. Okay, so if you look at this one, it's equal to 0, and we can now start to refactor this back out and figure out what those real factors we were interested in are. Is there a GCF? Why, yes. Yes, there is. 2 goes into all of this, and actually that just became really good news for us. It actually changes what method we have to use here, which is phenomenal. Okay, so you could still use the longer method, but if you notice, pulling the 2 actually got rid of that a value. So we could actually use the shortcut we had learned originally. I can jump right to 144 here. I mean 140, I apologize, negative 140, and find 2 factors of that combine to negative 4. And I'm going to think it's going to be negative 4 and positive 10. And then those are the actual factors. That's the beauty when there's not an a value, is that those are already the factors. That's a 10. And the 2's out here, and this is equal to 0. And now we could proceed. So the possibilities for the width here are anything that makes this be 0. So if this is one of my factors with a variable, one option for the width, if I add 14 on both sides, is that the width is 14 feet. My other option that would make this true would be if I subtract 10 on both sides, and I would get a width of negative 10. Now, we've done this before. Yes, both of these mathematically work in this polynomial, but do they both work as a width of a rectangle? Right? I think we all agree that a patio cannot have a negative width. All right? It can't be negative 10 feet wide, right? So it must be 14 feet wide. And in the problem, they said, find the dimensions. So we need to find both here. So now we can say, oh, basically the width is 14 feet. And if the length is 2 times twice more than that minus 8, then that's 28. Minus 8, that must be 20. So the dimensions must be 14 by 20. So this patio is 14 feet by 20 feet. Okay, those are the dimensions of our patio. Okay, so let's take a look at number 10. So in this one, what they tell you here is the sum of 2 numbers is 8. So you know they add up to 8. The sum of the squares of these 2 numbers is 34. So we have 2 unknown quantities. And this one's a little more complex because it's actually going to require us to think back to when we did systems. We essentially have 2 equations here, and we're going to do a little substitution to be able to set up our polynomial. So because we have 2 values, right, that we do not know what they are. So this is going to help us dig back a little bit to systems, which is awesome review. I love this problem. So it says we have the sum of 2 numbers is 8. So don't know what either one of them are. So we'll start by saying, okay, we got an x and a y, and they add up to 8. There you go. The other thing that I know is that the sum of their squares, right? So if I square the first one, and I square the second one, and I add that, that sum comes out to 34. Okay? So I want to know what the 2 numbers are. And we're not going to guess and check, so don't even think about it, because the whole point of this entire year in this course is to not guess and check. Okay? So we're going to use what we know about substitution in systems and solving polynomials, all in nice and, together, to solve this problem. Okay? So what I'm going to do is I'm going to solve one of these for y. So let's say I take this guy right here, and I move the x over, and I rewrite it so y is isolated. And then I'm going to use that substitution method that we learned last fall. So if y is equal to negative x plus 8, then I can take that expression and insert it into the other equation wherever I see the y, because they're equivalent, right? So I'm going to use that substitution. I'm now going to rewrite this guy, x squared plus, but instead of writing a y here, I'm going to write a negative x plus 8 squared. So I just replaced the y with that expression, because I know they're equivalent, equals 34. And now I have essentially what can be a polynomial once I clean it up, all in terms of x. So the first thing I want to remind you is that when we square this, it's going to be a perfect square trinomial. It is not going to be just this squared that. You can't distribute that exponent. You know, we've talked about that a bunch of times, but we do know the pattern is always the square of the first term, so negative x times negative x is going to be a positive x squared. The product of those doubles, so negative x times 8 is negative 8x, and if I double that, I'll get negative 16x, and then the 8 squared, which is 64. So when I square that, that's the trinomial, the perfect square trinomial that I get. Okay? And then I want to clean this up and set it equal to 0. So I'll combine my like terms. And then I'll take this trinomial here. I'll set it equal to 0. I'll say, hey, 34, come on over. There it is, right? And then I'll have this much more comfortable feeling, because it looks more familiar to us with what we're working now, polynomial, and it's equal to 0. And this right here is going to then allow us to use the techniques we've been using. Is there a GCF? There is. 2 goes into all of this. That's great news. That leaves me with, if I factor out that 2, that leaves me with x squared, negative 8x, and 15. And that actually allows me to use a simpler trinomial factoring method. So if I can find 2 factors that multiply to 15 but add up to a negative 8, then I'm pretty much almost done here. And I know that that is actually going to be negative 3 and negative 5. Those multiply to positive 15, but they combine to a negative 8. So I know that this factors into an x minus 3 and an x minus 5. And just a reminder, the only reason I can do this faster version is because a was 1. Right? There's nothing sitting right here in front of this x squared other than a 1. That's why I can get away with that. If not, I would do the splitting the middle term and factoring by grouping that we had been practicing. Okay? So this is the fully factored version. And now I use a zero product property to finish this out. And I just want to remind you that you don't have to worry about the 2 when we're considering the zero product property. I'm only interested in factors that actually have a variable. So x minus 3, x minus 5. Those are the 2 that I want to set equal to 0 and solve. And when we do that, we realize that x can be 3 or x can be 5, which means those are probably our 2 values, just because I didn't specify which one was which. But I'm thinking at 3 and 5, so let's test it. Does 3 plus 5 give us 8? So does it satisfy this initial relationship? 3 plus 5 is 8? Yes, it does. Does it satisfy this relationship? Well, let's find out. 3 squared is 9, and 5 squared is 25. And if we add that together, we do get 34. So 5 and 3 must be the 2 values, or the 2 numbers. So the 2 numbers are 5 and 3, or 3 and 5. There it is. Boom. That's an awesome problem. Okay. All right, we are going to put a pause. That's plenty of practice. And I actually really like the last 3, doing them live in class with you. So this is the end of what you're required to do on the video notes. We'll do 11, 12, and 13 in class together tomorrow.